So let's go into exercise 3.6 and I'll do some examples and hopefully that will help clarify things that we've got to do. So for question 1, we're given y equals 1 minus x squared and we want to find out what the area is between this function and the x-axis. Okay, so this function and the x-axis. And we don't need to have detailed diagrams, we just need to be able to draw an approximate sketch of what it is we're dealing with. X and y axis. Straight away, forgetting the 1 minus, you should see y equals x squared is a parabola. Because there's a minus there, it's an inverted parabola. And because it's a 1 minus, everything's been shifted up by 1 unit. So we're going to have an inverted parabola that looks like that. Its vertex is going to be here with coordinates 0, 1. And in fact, you should also be able to do in your head by this stage with extension 1 students, the values where it crosses the x-axis will be when x equals minus 1 and when x equals 1. And we want to find this area. Alright, so to find that area, because that's the curve, there's the x-axis, that's the area we're looking for between the curve and the x-axis. So to find that area, we just go the area is going to be equal to, the limits are from minus 1 to 1. The lower limit, the left-hand limit, always goes at the bottom of the integral sign. The right-hand limit goes to the right of the integral, it goes to the top of the integral sign. So we're finding the area between this function here, 1 minus x squared, and the x-axis. Now, oddly enough, that's all we have to put in there. We just have to put 1 minus x squared dx. And we'll see why that is a little bit later on when we start considering two curves and the area between two curves. We'll see why it's just this function and nothing else we need to worry about. Hopefully that will become clear. Let's integrate this function. So we'll end up with x minus x cubed, x cubed on 3, and that's from minus 1 to 1. We substitute in the x values, so we're going to have 1 minus 1 on 3 minus 1 minus minus 1 on 3. Now there's a whole bunch of algebra and mathematics and arithmetic that I've just assumed that you will pick up on why it is that this is 1, why that's 1 on 3, because 1 cubed is 1. And here the minus 1 goes into there, that's a minus 1. Minus 1 cubed is a minus 1. Right? So all of these things are, you should be able to pick up on that very quickly and understand without much explanation why it is it looks like that. So if we eliminate these brackets, the round brackets inside the function, the square brackets, then we'll have 1 minus a third plus 1. Now that's a minus and a minus and a minus, so that will end up being minus a third. So we'll have 2 minus 2/3, which equals 1 1/3 units squared. Please put in the fact that it's units squared. We're now starting to talk about areas, so put in that it's units squared. It may be that in the answers all at once is the answer as 1 1/3 or 4/3, but in most situations we'll be talking about areas, so let's just get used to the idea of using areas. It could possibly say in a textbook, evaluate the area between, or evaluate the area between that function and the x-axis. Still, it's an area, so let's put the units of area there. Alright, I'm going to move on. These notes here are going to have to get scrubbed so that we've got room for our next examples. You can always come back to these notes and look at them and write them down if you like. The next example we're going to do is question 6 from exercise 3.6. And we're given the function y equals minus 2x squared minus 5x plus 3. And we want to find the area between that function and the x-axis. Right, so with this one, what we want to do is get an idea of what it looks like. You know what, it's a quadratic, which means we'll have a parabola. Let's find out where it crosses the x-axis and the y-axis, and we'll do all that stuff from chapter 5 in the preliminary course. I'm just going to look purely at this function, and just to make things simpler for me, I'm going to take a factor of minus out the front of these brackets. And now I find it much easier to factorise this expression, and that's going to have to be 3 and a 1, and that will be the plus, and that's the minus. So it means at x equals 1 on 2 on half, and at minus 3, that's where it crosses the x-axis. And to find out where it crosses the y-axis, you just make x equal 0, so it crosses the y-axis at 3. And if I do I could even put y equals 0 at x equals these values. Just a quick sketch. Right, here's x, the y-axis. We know that when x is equal to 0, this function is equal to 3, so we'll put a point up there. And we know that it crosses the x-axis at a half and at minus 3. So the function kind of goes like that, roughly. We don't need to know where the apex is, that's not important to us. What is important is that are these limits, the minus 3 and the x equals a half. They're important to us. And we're looking for this area in here. So to find the area, it's going to be the integral of minus 2x squared minus 5x plus 3 from minus 3 to a half, all with respect to x. We integrate that and we get minus 2x cubed on 3 minus 5x squared on 2 plus 3x, and the limits are from minus 3 to a half. So next step, we put these values into our expression. Be minus 2 times a half cubed on 3 minus 5 times a half squared on 2 plus 3 on 2 minus, we put the y value in there, and that will be minus 2 times minus 3 cubed on 3 minus 5 times minus 3 squared on 2 plus 3 times minus 3. It's all starting to blur into our notes over here, so maybe I'll get rid of these two for the moment, or forever, because we don't really need to refer back to them. Notice how this is not an even function. It's definitely not an even function because it's got no mirror symmetry. It's not an odd function because if I put a pin in the origin, then you rotate it 180 degrees. It's not an even function. So the area comes out to be 333 over 24, and that's the improper fraction, but you can work out what that would be as a mixed numeral. I'm not sure how the textbook's going to present their answers for that one. I may have done a little bit of a mistake somewhere in the arithmetic, but the principle of how this gets worked through, this solution, the principle is correct. If I've made some silly mistake, some avoidable error in my arithmetic and doing all of this as mental arithmetic, which you ought to be able to do, then don't judge me because of the answer being wrong. In an exam, we're more concerned about the fact that you know what to do rather than that you get a number that's right. Because all sorts of things can lead to getting numbers incorrect. Stress being one of the factors.